In this lecture, we're going to have the last example on a directory traversal or a path traversal vulnerability. It is a little bit more restrictive than usual, and it just shows you another common security implementation that programmers might be using to stop you from exploiting such vulnerabilities. But as you'll see in this lecture, it is easily bypassable. And as I said in the previous lecture, you might have to combine a number of the tricks that we learned so far. So you might have to use all of them or some of them in order to discover a bug in a certain target. That's why it's good to see or to practice as many as possible. So we have a target right here that looks similar to all of the targets that we've seen before. We're going to turn on our proxy, load the product, and we're passing this one and we're sending the next one to the repeater because it is the vulnerable one. As you can see, we have an image endpoint. The file name is the name of the parameter and a value of an image is being passed to it. If we send it, we're actually gonna get the image in here, and let's try to just load something else. So let's go to the proxy, turn it off, and just get another image. So we're just gonna go to the repeater and let's just load an image that is called 60, send it, it loads, and therefore we have a strong indication that the target might be vulnerable to a path traversal or a directory traversal vulnerability. So we're gonna spend more time on it. You're gonna try everything that we've done so far. So again, you're gonna try your simplest one, starting with the simplest, etc password. It's not gonna work. You're gonna try the dots. It's not gonna work. You're gonna double the dots. It's not gonna work. You're gonna do your null byte. It's still not gonna work. So you're gonna end up thinking this target might be really not vulnerable. But that's still not enough. You should try even more. So what we're gonna do is we're gonna first of all add the dots. So we're gonna add a few dots and we're gonna send it, and it's not gonna work. So what we're gonna do, we're gonna URL encode the special characters. So we're gonna URL encode the /, and you can do that by right clicking it and going to the convert selection, URL, and we're gonna say we wanna URL encode all characters, and that's basically gonna transform the / to its URL encoding. So %2f. So basically what we're trying to do is we're trying to say the same thing differently. We're still trying to tell the web application to load a / or to accept a /, but the reason why we're writing it like this, because we are assuming that the target web application has some kind of a firewall or a filter that is checking if the value sent to it contains a /, and if it does, it's denying our request, or maybe it's removing it. Therefore, we're trying to pass a / to the web application differently so that it bypasses the filter but still gets executed as a /. So I'm gonna copy this and just simply do it to this one and this one, here and here. We're gonna send it and it still doesn't work. So at this stage, you're going to be like, well, definitely this is just not vulnerable, and you're going to move on. But you should try harder, because the target firewall might be smart, and maybe it's actually even checking if the input is being URL encoded. So basically the firewall might be taking your input and basically doing what I'm doing in here, convert selection, and doing URL decode on it. And that'll basically transform it back to its original form, to a /, and then it's checking, does the input contain a /? And it does. And then it's denying you from accessing the file because it knows that you're trying to do something malicious on the target. So basically, the web application is URL decoding your input, it's changing your %2f to a normal /, and then it's checking if your input contains a /, and it contains that, and that's why it's denying it and it's stopping you from loading this file. So what we're gonna do, we're gonna double URL encode our input. So basically this is the first encoding, and then we're gonna encode it again so that it looks like this. Then the firewall or the filter is gonna URL decode it, and it's gonna change it back to this, which is the same as what we had in here. and that still doesn't contain any forward slashes, and that's why it's gonna pass the firewall, hopefully. And then when the web application actually read this, and because it's a path and it's only URL encoded, it'll understand that the %2f translates to a normal forward slash, and therefore it'll hopefully load etc password for us. So let's go ahead and do it. So this is the first URL encoding. We're gonna do it again. And if we go to the raw, perfect. As you can see, we are able to load the etc password file, the file that we want, and we managed to exploit a path traversal or directory traversal or discover it in an input or an endpoint that really didn't seem like it's vulnerable. Now, I will include a cheat sheet that includes a lot of other ways of discovering path traversal, but what we covered so far is the main ways that programmers implement to prevent such vulnerabilities, and therefore these are the main ways to bypass the filters that programmers might implement.